which is Mr. Greg Hutton from the Geodata Institute of the University of Southampton, and in charge of the user component of things.
Okay, thank you very much. As the introduction has told you, we're sort of sister projects now. There's two projects going to be presenting here, and we have some overlaps and we have areas where perhaps there's some additionality. The project itself has 4 university-based partners across Europe, so it's a similar sort of funding scheme, EU funding scheme. We have the University of Manchester, so I should have put something up, which are sort of IT architecture specialists. Southampton University, where we have a user group, which is the group I'm from, a particular interest in how users engage with information and how users get engaged with the technology. But also at Southampton, we have the ECS group, which Kirk will be talking later on. And apart from being all-rounders, they're very interested in the applications and how we actually get users applied and the applications within the system. We also have Athens and Madrid. Madrid is leading, and Athens carries out the registry stuff. You'll hear about this later. We also linked up with a number of private sector organizations. In Spain, there's a group called Demos. They're actually carrying out the same process as us, but in fire. So there's a fire and flood component.
Okay, so the principle behind, so there is also a fire process going on in parallel to this. So really the underlying idea is that we developed an architecture to be able to grab information, but there were 2 applications that were required. So we put a hand up at Southampton and said, well, we're interested in coastal flooding, so perhaps that would be a good example, and they said great, and then there was one about fire. Now it's called Sensor Grid for Environment, so this is quite complicated. Semantic, it's meant to sound like sensors because it's meant to use sensor networks, just as Urban Flood uses sensor networks. We use a series of lifetime sensor networks, but of course being very clever, we decided to use sensor as in semantics, because the concept behind this is that a user who is not particularly technical, although we are reasonably technical, we can represent people who do, a user will be able to go onto this system and request information. I am a flood manager, I'm a fire manager, I want this kind of information. I want to know where ships will be, I want to know in 6 hours time what the tidal state will be. I want you to show me where the important assets, industrial assets are in this area. And that the system will semantically, so be able to utilize your words to go off, find that information and make a mashup. This mashup sort of scraping information together from our perspective and sticking it on a screen. So it's meant to be dynamic, it's meant to be user-driven and a highly dynamic system. The world is not like this yet, but the idea is this is a sort of horizon-searching approach, where we hope in 10 years' time perhaps, people will be putting their data sets on with the right front, sort of RDF front, or some sort of front that allows us to grab that information, to search through it, to understand it, and stick it in what I call the sort of universal joint, stick it into one thing that allows people to look at it. And that's quite a simple principle, and obviously incredibly hard to do. What we were trying to do, therefore, is if we're looking at a future that uses, and this shouldn't be, I mean, it's called grid, but now we should be saying cloud now, cloud technology, sort of accessing the large amount. The idea, the philosophy behind this was that we would be able to engage in development concepts. How would it be that users in the future, real users, would engage with this system?
Can you please repeat that, what you just...
No. Okay, so sensor grid for the environment. The concept is it's semantically search system. You semantically search information from things like networks and standard baseline data sets, so that managers, flood or any environmental manager, would be able to access information across the internet and rapidly assimilate it into a single map which they could use to make decisions. And we're a long way away from that at the moment, but this is kind of horizon searching and conceptual. So what we did was we engaged with real users and said, how would you use a system like that? We're setting one up, and sometimes we're just demoing it, sometimes we're using data because it doesn't necessarily exist out there, but we say in future it will. So we are, as users, exploring that future. Just to mention, we're part of a certain work package, which this happens to work package 7. You'll all be familiar with these sort of work package concepts in Europe, I suspect. But we've made sure that right the way through the process, users are engaged. We've had the user engagement, the sensor deployment, but we go to the users to find out what data they have. We go to the users to find out what data they need. How do they use their data? And our architecture and applications people are with us at the user meeting because they're interested in how, and some of you may be those users, how users actually use information. And I think sometimes in a lot of projects we always talk about users, we don't really go into depth with users about the way they use information and how they see the future of their use of information. And then we've asked them to develop scenarios. Imagine scenarios of how they might use a system, a flood management system. And in fact, we analyze their scenarios in great detail. One for ontologies. This is this sort of torturous approach where if you want a system to be semantically searched, the system has to understand the language you're using. And ontologies is this method by which you lay out what each word actually means and what it means in relation to other languages and other disciplines. Is extremely tortuous. So we spent time looking at the ontologies to bring the computer into the discussion, as I call it. And so the scenarios were a powerful but quite complicated tool where we've actually selected 2 major scenarios to work with. And really at the end of this, what we want is a demonstration. And it really will only be a demo. We will have a tool. It will draw from the internet, but it's some bits that we're going to have to kind of make up almost to say, but in future we will have access to this kind of data, future we'll have access to that. Most of it will be there. But as we say, this is horizon searching stuff. Here is the concept of SG4. You're going to get a lot more from Kirk. And also we have Robin here, who's from EMU. Sorry, I finished at the fire thing. We have Demos as the application people in Spain. And we have the application people here also EMU Limited, which is a private sector company we're working with in their sensor deployment. And they will be talking, a little bit later. So the very, for user people like me, they've laid it out nice and simply. We have a data tier. This is the sort of resources, and in the end, this may be the cloud, data source connectivity. You have the middleware tier, your semantic layer. This is where the search going on. The ontology would sit in here. So this is the process where you can put in what you want and the system is working out what it needs. And then the application services, this is those mashups. This is what's stuck on your screen and what I say as a user, or you maybe as a user, actually develop in order to be specifically applied. And in our case, that application is flood, but there's another application in fire, and let's be honest, you could apply this to any system. So, okay, fine, data management, ontologies, the registry, this all leads into the API and to the flood use case in ours. We are currently in the process of, this is how we've engaged with the users construction. What we did was what we call a straw man. We developed an initial scenario. We said, okay, let's assume these are the things people are interested in flood. And then we went to the end users and said, what do you think? And they said, no, that's not how we do it. Or yes, that's okay, but you need to change it like this. You have to give them something. You can't start with a blank screen. Then we recruited very specific users. We went to a lot of people here. And then we targeted those who were particularly interested, those who particularly had an application. And also the ones we picked tend to be the ones who were saying, in the next 5 years, we need to be doing this. They were the ones who were already looking to a horizon. So we picked 3 of them and 2 of them we've continued with. Those are the key users. What we've now started doing is an iterative process in the last year with these users. And we found it a very powerful tool. If you develop a system, keep going back to the users and getting them to say, use it. And they go, no, that didn't work, this does work, that didn't work. And keep tightening the system, this iterative process. So these are all the users that we talked to in Southampton and in the Solent region. which is, I should say, Southampton sort of in the middle at the bottom of the UK, but it's just a coastal region of industrial importance in the UK. So we talked something called the Solent Forum. These are the government agencies. ABP's Associated British Ports. It's a large private, but was once a government agency, which runs most of the ports. We have the Channel Coastal Observatory. This is where we get a lot of data, and I think you'll be talking, Robin, about the Channel Coastal Observatory later. Harbour authorities, federations, businesses, you get the idea. We went and looked at a wide range of stakeholders and users. The ones we've marked in here, we then invited to a very specific workshop, and these people came along and we talked in great depth with them and showed them a demo and said, this is the concept that we're going through. And in the end, we recruited ABP, Associated British Ports, which is a very large organisation, runs 23 of the large industrial ports in Britain. And they have a specific scenario they're particularly interested in, and something called the Coastal Defence Partnership Board, or CDP, which is a government, which is a sort of local authorities run coastal defence group, which has an interest in flood management and coastal management, and is looking to the future. So we use those two. In the case of ABP, what they said to us was, look, we want a system, and there is a demonstrator which will be out there, which we can show you. Talking about this, but what we did was listen to what they do, and this is Southampton water in here. This is the Isle of Wight, so you're in the sort of bottom middle bit of the UK. Shipping comes in from around the world, and this is where they put pilots on, in this region here. This is where they send out the pilot, they get on the ship, and then they take the ship in to the harbour, because you have to have pilots who know what they're doing. And the two things that concerned them about this were, one, that as they get here, what is the weather conditions going to be, and specifically the wave state, and which way are the waves coming? Because the ship, in order to be able to get their boat to actually transfer, they often can't. And American tourists on big cruise liners get sick, and that's not good, apparently. And then what happens is they have to come in here, but they have to come in under the right tidal conditions and also weather conditions. So they have a great deal of money tied up in ensuring that this happens quickly. If they lose a large ship by an hour, costs huge amounts of money, and also there are security issues, etc. So they said, well, could you tell us in 6 hours, 8 hours time, etc., and gather together all the information we need to tell us whether we can do this. And one of the things that Robin will be talking about, and we have a couple of PhD students here, is developing forecast models for the tide and sea state conditions here, which is probably one of the most dynamic elements. So what, of course, we need to do is understand the weather systems. We need to understand the sea state in, say, 3 or 4 hours' time, and give them that access. We also need to understand the tidal state. And we need to know where the shipping is, and that's broadcast. So this is a classic mashup. We'll go and grab all the shipping data, we'll grab the weather forecast for 3 hours' time. We've got a couple of people here doing PhDs on how do you forecast sea state that far in advance. But ABP will be a user, and this is a scenario they said, go away and work this up. The other one, as I said, was Coastal Defence Partnership, and they work in these authorities, don't worry about those names, but here, this is where we were just now, but they work, and their job is to defend Portsmouth, which is a large and significant city on this region, and their task is to defend that region more broadly, and for coastal flood forecast. Now, they use all the same information in that they want to have tidal information, they want to have wave information, but they've also got CCTV cameras which look at their coastal defences. So we're going to use their bespoke data. That's unique data to them. We'll grab that, stick that in. And we've got lots of baseline data on the state of coastal defence, ecosystems we have to protect, military areas. You can imagine there's a lot of data. So the system, a user needs to come on and say, I want the latest data on this. And by the way, I'm interested in butterfly habitats up here. We always use that as a case study. Somebody should one day be able to come on and throw what we call the curveball in and say, and I'm also interested in something that has not been pre-programmed. So the system must go off and find that data for me. We're not there yet. In the end, in our scenario, sorry, you probably won't be able to read that, but these are the data sets we decided to actually use. This is neither here nor there for you, but it's coastal defence, something called Branch, which is our ecological data sets on the coastal, the coastal zone. We've got weather, we've got cars, we've got traffic information, we've got where the main assets are, CCTV, shipping data. Generally speaking, we've settled on a series of data, but of course, in the end, we want it to be in the cloud, and we want whatever you want to be accessed. And this is just a demo of that principle. So that's SG4 in principle. That's what we're aiming to do, and Kirk will talk a lot more about the technical details if you're more the ITC. And Robin here will be talking about that modelling future, where we're looking at the Met Ocean and the coastal defence models, which are so important to the system, all using a deployed sensor network. We've got this Channel Coastal Observatory has buoys out at sea transmitting information to us reliably all the time, and this is our utilisation of sensors. I think that's okay.
Okay. Any questions for Greg? Thank you.
Where do you see the...
You need it? Yeah?
Good morning, Eric Peters from Alert Solutions. I was wondering, this is a lot on coastal defense as well, and shipping traffic. Where do you see the main connection or collaboration with the Urban Flood project?
I think the main connection that we have to first come across is less to do with users, more to do with the sensor networks and how you utilize the architecture of sensor networks in a real-time and adaptive way. And when we first looked at what Urban Flood was doing, that's probably where most of the money's going. Although we're interested in this, a lot of the interest is how you use and manipulate into a mashup environment the sensor network material. Kirk, Kirk will be talking a little bit, he's a particular sensor network person, but I think that's where the key overlaps. Though, are there other areas that we should be considering? I mean, I think the network was the one I felt was the closest link, but users network.
Well, when we talked together, we noticed that we are rather complementary. Because as G4E looks at coastal environments, we look at urban environments. You look at loading parameters.
Yeah, that's very true.
And Urban Flood is more looking inside the dike and looking at the dike strength. So the projects are complementary. There's one thing where we can cooperate. That you do quite a lot of things on the semantics and the ontology, so I think we could learn from that from you.
Yeah, well, I'd agree. And we're going to, as you say, we've got Matt over here, Matt Wadey, who is doing his PhD studies on fragility curves for the failure of defense systems. And whilst from a user perspective, there's been a lot of interest expressed in how do we come up with probability of failure for our flood response people, Environment Agency, etc., and this Coastal Defence Partnership. They want to know how to position resources in advance, and a lot of their studies are linking up. And I think probably your polder work, and we see a bit of this on the dike failures, there's definitely some link-ups between those as well. So.
And there's of course one important message. Yeah? Internet and internet technologies will be driving these type of developments. There will be no single dedicated system anymore. We will deal with a heterogeneous amount of data. We will deal with any source of information which is available. And we are just creating the systems for that. We are allowing others to add value. And that is an open system. And this is the things this is the common message.
Yeah, I would agree with that strongly. That seems to be an important element. Are we okay?
Other questions?